Today I'm going to talk about the next project that I'm starting working on now. I'm going to build a piece of software, a service that can convert orthophotos into a CAD 3D rendering of a site. And the reason that I'm working on this is that I made a friend through an acquaintance who runs a business doing this without machine vision in the process. So he uses all of the drones and has a lot of really cool technology, but is using manual operators to convert photos into a 3D rendering in a CAD program. And the way they do that is some sort of like 3D glasses and a program where they can move throughout 3D space using stereo imagery and mark different things in the photo. And then they actually hand draw and hand mark where each thing is. Hey, you can do all this stuff now with machine vision. You should talk to Brian and he can help you. We met up and I think it's a cool project to work on. And I've done some initial tests, but before I get into that, I want to show you what sort of a CAD drawing of something like this looks like. And here's a good example showing all the parking spaces and trees and manhole covers on the sidewalk here and on the roadway, parking spot markers, tree location. All this stuff was hand drawn using drone imagery as a guide. Photography is stitched together and mapped into a global space. There's one giant photo aligned to the latitude and longitude, and what you end up getting is a very accurate photograph that's an orthogonal photograph of the site. Person can come in and actually draw, sort of trace that in 3 dimensions into a CAD program. So I think we can actually automate that using machine vision and a little bit of deep learning. I want to show you what an orthophoto looks like. Okay, so here is a good example. And you can kind of see all the same stuff here, trees, and you can see like, I think we looked at a manhole cover somewhere over here. Yeah, a couple right here, and here they are. The idea here is to take that orthophoto as a source for the machine vision model to recognize certain things within that photo. So we can recognize things like trees, I believe, and manhole covers and valve covers. I'm going to embark on doing it one bit at a time and try to create value from each thing that I can convert into that space using machine vision. Doing that will actually save money and time for a company like my friends. So first I've got this orthophoto, which is composed really of a lot of sub photos, and it's all stitched together. And it's huge. It's like 100 megabytes, maybe even bigger. It's a single photo. It's not like a super high resolution photo, but it's fairly high resolution, right? So we got that much detail. It's not super detailed, but there's enough to see that that's a manhole cover. My general rule of thumb with this machine vision stuff is that if a person can reliably identify something in a photo, then the machine can do it too. Any imagery from the sky ends up having a perspective. This orthophoto removes a lot of that perspective. Everything you're looking at is directly orthogonal. Orthogonal is like if you have a plane and then you come orthogonal to it, you're directly at a right angle. Taking that orthophoto, it's too big to run through a machine vision program. I need to break it into smaller pieces. I also need to train a model to recognize the things in these photos. One of the things I think that would be particularly easy to recognize are manhole covers because they're all kind of the same and their shape is very consistent. So I've divided that orthophoto you're looking up into 200 pixel by 200 pixel sub images. And then I've gone through and found all the images myself that have manhole covers in them. And then I've created a mask or a polygon that describes the exact outline of the manhole cover. I've trained a model to recognize those manhole covers. It will draw an outline around exactly where the manhole cover is. Once I've done that and created a model that can do that, I can take other ortho photos and I can bring them through that same process of breaking them into 200 pixel or going through each of those images. I can run them through my model, and then out comes some detections. And those detections have a location within the photo space. And so I need to know, like, in this grid where this photo was located, and then I need to know what each pixel maps to in terms of the global scale. I can then map that into a format that is importable into a CAD program. A company like my friend's company can actually take that file, that DXF file, the drawing exchange format file, and import a single layer, say a layer with only manhole covers into their process, and they just start from that point. And so I just wanted to prove it to myself because I am a little bit new to this space. And so what I did is I went in and I created a model using this ortho photo, and I reserved some of the manhole covers for testing and validation data. And it didn't take many manhole covers to train this thing to work. I think I had something like 20 total manhole covers, and I split it into 70, 20, and 10% train, validation, and testing. I was able to very accurately identify the location of the manhole covers in the final test set. That's really promising. Now the next step then is to give an output, to deliver something. The format that I'll be delivering things in is something called a DXF format. The actual manhole covers marked in a DXF file. So these are all the manhole covers from that ortho photo already into a layer in a DXF file, and you can see them here. Instead of paying someone to create it, the machine will create it for like half the cost that he would pay a person to do it. Once I train the model, it's very fast. It takes only a minute or less to run all those images through the model and get all the detections out. So yeah, that's the idea. That's the project that I'm working on now, and I just wanted to share that with you to show you the kinds of things that you can do with a little bit of machine vision, drones, and just a little bit of know-how and hacker mentality. Hopefully get something done in the next few days, and I can share it with you and show you how it works. Until next time, thanks for watching.